Good morning, ladies and gentlemen. Welcome to our next step in learning of integration, and this is integrating by first differentiating. It is a favourite of the examiners. It comes up in almost every past exam I've seen, and essentially they guide you to integrate something tricky by first differentiating something. And I'll show you what I mean by this. So, a couple of examples. Find the antiderivative of e to the 3x plus 1 by first differentiating e to the 3x plus 1. Alright, so let's look at e to the 3x plus 1 dx. So differentiating it, if we find the derivative of it, 3e to the 3x plus 1. So that's the derivative. What we can say is once we've found the derivative, we know the relationship between the two. So if we find the integral of the derivative, we get the integrand, or the original function, e to the 3x plus 1 plus c, because we don't know exactly where it's come from. So what this is saying is if we differentiate this to get that, we can then integrate this to get that. Now, note here, at this step, it's worth looking at the relationship between what you've got and what you want. So here, we want to differentiate e to the 3x plus 1, and we want to integrate e to the 3x plus 1, but what we found is we're integrating 3e to the 3x plus 1. So we're close, but not quite there. In order to get there, we need to get e to the 3x plus 1 on its own inside that derivative, that integral. So we pull the 3 out the front, because with constants we can just pull a constant out the front. Note that we couldn't pull out the 1 or the 3x up there, or the 3, because they're part of a function. But the constant sitting at the front, we can pull out the front, equals e to the 3x plus 1 plus c. And at this point we can divide both sides by 3. So if we divide both sides by 3, what we get is the integral of e to the 3x plus 1 dx is equal to a third e to the 3x plus 1 plus, what we could write as c on 3, but that's a little bit silly because a constant divided by a constant still gives us another constant. So by convention, we don't actually do anything to it, we just leave it as plus c. So what this is saying now is that the integral of e to the 3x plus 1 dx is equal to a third e to the 3x plus 1. Alright, different example. Take d here. We want to integrate this by first differentiating that. So let's look at 2x plus 1 to the 4 and differentiate it. If we differentiate it, we get 4 bracket 2x plus 1 to the 3 times 2, because that's the derivative of the inner coming out, so you could think of it as 8. Fair enough. Alright, now let's reverse this relationship, and we can say, well, if I integrate 8 lots of 2x plus 1 to the 3, what I will get is 2x plus 1 to the 4 plus c. Alright, and we can see that inside the integral is pretty close to what we were after. The only thing we have to deal with is that pesky 8, which can come out the front. Integral 2x plus 1 to the 3 dx is equal to 2x plus 1 to the 4 plus c. Divide both sides by 8. So the anti-differentiation of 2x plus 1 to the 3 dx is equal to 1 on 8, 2x plus 1 to the 4. No, you could just write it as over 8, plus c. Plus c is important. We need it, but we don't need to divide it by 8. Alright, by considering the derivative of x squared take x to the 3, find the integral of 2x take 1 bracket x squared take x to the 2. Now that doesn't look particularly pretty, so let's just follow what they've said. Find the derivative of this. Well, the derivative of that is going to be 3 bracket x squared take x, and that then is going to be multiplied by the derivative of the inner. The derivative of the inner in this case is being 2x take 1. Alright, so what we can say is that if we find the integral of this, we will get back to x squared take x to the 3 plus c. So the derivative of that, if we integrate it, we get back up there with a plus c. Alright, now we can see that this is actually pretty close to this. The only relationship between the two, or the only issue, is that 3 that's popped out. So that 3 we can divide away to the other side and write this as the integral of x squared take x squared to 2x take 1 dx is going to equal to a third x squared take x to the 3 plus c. Alright, so to integrate this, that's what we get. Alright, next example. Find d dx of x sine x and hence differentiate x cos x dx. Sorry, hence integrate x cos x dx. Alright, let's derive this. It's clearly product rule, with u being x and v being sine x. U dash is then 1, v dash is cos x. So d on dx is equal to x cos x plus sine x. Alright, so that what we can say is that the integral of x cos x plus sine x dx must equal x sine x plus c. So what we're saying is, okay, if we have differentiated x sine x and got out this, we can integrate it and go back there, but with the plus c. Now what we do is we do integral of x cos x dx plus integral of sine x dx is equal to x sine x plus c. Now, the reason we've done that is because there's a plus there, we can split it in parts like we saw in the previous video. And the cool thing here is we've been asked to integrate x cos x. After our split, we've got this here. We're integrating x cos x dx. And now it requires some algebra that feels odd, but actually makes a bit of sense. So if we've got that and we want it on its own, we can take away this integral here. The integral of x cos x dx is equal to x sine x plus c take the integral of sine x dx. So we're removing an integral over there, and you can move integrals around like this, that's okay. So then let's simplify. X cos x dx is equal to x sine x plus c. Now integrating sine x. Sine x has come from a cos x. Cos x, though, changes sign. Because it's positive there, it must have been a minus cos x. That minus is going to combine with this, so plus cos x. And really, because we're integrating, we'd normally put a plus another c on the end. Having two plus c's in there is weird, and you don't write plus 2c, because two constants just make another constant. So what we normally do is just write one constant on the end. Alright, so the integral of x sine x plus cos x plus c is equal, well, that's equal to that. Note that we can check this by differentiating this. If you differentiated that and simplified it down, you should end up with x cos x. Kind of neat, huh? Alright, last example. And the last example comes from a past exam. They've cut it straight out. So, I've cut it straight out. Y equals x e to the x, find dy dx. Simple differentiating. With u, v, then u dash is 1, v dash is minus e to the minus x. Therefore, the entire thing is x minus x e to the minus x, that's those two, plus these two, e to the minus x. Alright. Hence, show that the integral of x e to the minus x is equal to minus x e to the minus x minus e to the minus x plus c. Alright, so once you've differentiated it, you can set up a relationship. So what this is saying is if we find the integral of minus x e to the minus x plus e to the minus x dx, that will get us x e to the minus x plus c. Essentially what we're saying is if we differentiate this to get that, we can integrate this to go back. Alright, now, how does this help us show? Alright, what we need to do is split it up. The integral of minus x e to the minus x dx plus the integral of e to the minus x dx is equal to x e to the minus x plus c. Alright, now what do we want by itself? What we want by itself is an integral of x e to the minus x, which is pretty close to what we've got here. Pretty close, but there's that cheeky negative in there. Remember, we can chuck the cheeky negative out the front. So let's just get rid of it there and throw it out the front. And then what we're looking for is to get this portion here by itself. If we're looking to get that by itself, what we do is we have to take the integral of e to the minus x over from both sides. So it's minus the integral of x e to the minus x dx equals x e to the minus x plus c, take the integral of e to the minus x dx. Alright, keep going. Now, don't try and rush through the steps. Do it one at a time. Like, we could be getting rid of this minus right at the front now, but that's just going to rush things. And there's no hurry whatsoever. Now let's deal with this. The integral of e to the x, e to the minus x, it's clearly come from an e to the minus x. When you differentiate e to the minus x, it throws out a minus 1 to a sign change. That is just plus e to the minus x. Because if you think about getting the differential of e to the minus x, that gets you minus e to the minus x, which is what you have there. The minus can come in there if you like. I'm not going to put another plus c on the end. I'm just going to combine the two c's to make a plus c there. Now, we haven't quite got what we wanted by itself. The integral is not fully by itself. We need this negative over to the other side. So we can divide both sides by minus 1 is equal to negative x e to the minus x minus e to the minus x. Now, really, minus c, but minus c is just another constant, so we just leave it as the end by convention as plus c. And that is hence shown. Not pretty, and that's the hardest type you'll see, because that's one of the ones from the exam, but hopefully you can follow the logic between the relationship of differentiating and integrating, setting up an equation, and therefore solving for part of it as guided. Alright, see you tomorrow. Thank you very much.